Hey guys, just trying to finish up this lesson. The last part of this lesson is on the properties of the binomial distribution. Binomial distribution is pretty simple. Um, when you do the binomial distribution, what can happen? What does the prefix by mean? Well, the prefix by means two. All right, so two things can happen in the binomial distribution. So that's like the first property. The first property is that you have what we call a failure and a success. All right. If I send somebody to the free throw line and they shoot 10 baskets, either they make the basket or they don't. Okay. I send somebody to the driving test, either they pass the test or they don't. Okay. So only two outcomes. All right. Now, when you're doing a binomial distribution, you have to have a finite number of trials. All right. I send LeBron James to the free throw line 10 times. Okay. And I have to know that there's a finite number. All right. The trials are independent. So what that means is that the probability that you make the first basket doesn't affect the probability that you make the second basket, doesn't affect the probability that you make the third basket, and so forth and so on. All right. Trials are independent. The next one is that the probability of success doesn't change from trial to trial. All right. So those are kind of the major properties of the binomial distribution. All right. So when we go to do these problems, I have to tell you three things. I have to tell you an N, a P, and an X. Okay. There is a formula that goes along with this, but you're going to be using a table, so I'm not going to necessarily give you the formula in this video. I want to make sure that you know how to use this table. Okay, so the table is in Blackboard, and I want to make sure you know how to read it so that you can get these problems right. So this one says we want to assume that the random variable has a binomial distribution, and we want to find the probability for each one of these things. So we want to find the probability that x is equal to 3, given that n is equal to 5 and p is equal to 0.4. So I'm going to go to this table. Now, when you look at this table, it looks a little bit daunting with all these numbers, I agree, but it's really simple to read. Along the left-hand side, there are numbers on what we call the outside of the table. All right. The number most to the left is your n. All right. The number across the top is your p-value. And the number that is inside the n's are the x's. Okay. So if we go back to the problem, it says we want n is equal to 5 and p is equal to 0.4 and x is equal to 3. So I'm going to go to where n is equal to 5. So I'm right here in this column here. So I'm only in this part of the table. All right. And then it says p is equal to 0.4. So I'm going to read across this table to where it says 0.4. So I'm in this column, right? And in this column, in p is equal to 5, I'm only looking at these numbers, okay? Again, n is equal to 5, p is equal to 0.4. Well, the next thing it says find p that is x is equal to 3. So I'm going to go to this table where 5 is. I'm going to go to x is equal to 3. So I'm looking right here, and then I'm going to marry that to the 0.4. And that is this value here. Again, 5, 0.4, and 3. So that is this value 0.2304. Now, different charts read different things, all right? So depending on which chart you're looking at, it might be a little bit different, okay? I created this chart. I don't use the one that is in the book. The book has the same numbers. It just might be read a little bit differently. But outside should be N. Inside of that should be your X. Across the top should be your p-value. All right. So the answer to this one is 0.2304. All right. So let's look at the next one. It says N is equal to 10, P is equal to 0.3, and we want X is equal to 4. So 10, 0.3, and 4. All right, so I'm going to go over to the table. I'm going to go to N is equal to 10. All right, so N is equal to 10. I'm only in this chart. P is equal to 0.3, so I'm only in this column. All right, and X is equal to 4. So I'm going to marry that with the 0.3 column, and there is my answer. Again, 10.34 gives me 0.2001. All right, so my answer here is 0.2001. Okay, so what does that look like in terms of a problem? All right, it says a quality control expert at a large factory estimates that 10% is a probability. So P equals 10% of all batteries produced are defective. If he takes a random sample of 15 batteries, so he's telling you he's taking 15 batteries, what is the probability that exactly 2 are defective? So the probability that exactly 2 means X is equal to 2. All right. So we have a P of 0.10, an N of 15, and an X is equal to 2. All right. So we can go to our table. I'm looking for 15. So I'm going to go down to 15. All right. So here's 15. And we know P is 0.10. So P is 0.10 is right here. And we want to know that the probability exactly 2. So I'm going to look for 2. And it's going to be this value. Again, N is 15. My p-value is 0.10. And my X is equal to 2. So my answer is 0.2669. And that would be my answer. And I'm done. All right, so let's look at the next one, which is a U-try. All right, it says the probability of a plant surviving in Tyler's garden is 0.8. All right, so this time they actually gave you a probability, 0.8. All right, it says suppose he plants 19 plants. All right, so my N is equal to 19. What is the probability that exactly 5 of them survive? So we want to know the probability that X is equal to 5. All right, so 0.8, 19, and 5. So I'm going to go over here to my table, and I'm going to look for 19. All right, 19, and 0.8 is all the way over here. Now, and I want the probability that X is equal to 5. All right, so all the way up to 0.8. Well, there's nothing there. What does that mean? Well, when there's nothing there, that is 0. It means those probabilities are so small that when I round to 4 decimal places, it gives me 0. So the probability that Tyler's garden has a plant with only 5 plants that survive is equal to 0. Okay, so let's look at the next one, which is the inequalities. All right, it says the probability that it will rain during any day of spring break is 0.3. So it's telling me that my probability is equal to 0.3. says if spring break is 7 days, so n is equal to 7, find the probability that it will rain at least 3 days. Okay? So here's where you have to remember what those at least, at most mean. All right? At least means that it is greater than or equal to 3. Right? So what numbers are greater than or equal to 3? All right. So that is a 3, a 4, a 5, and how long do I have to keep going? Well, my n is equal to 7. So I have to do 3, 4, 5, 6, and 7. So I need to find each one of those probabilities and add them together. Well, that's in my table, right? So we have n is equal to 7 and p is equal to 0.3. And we need 3, 4, 5, 6, 7. So 7 is way back up here. All right. And we want 0.3. All right. And we want 3, 4, 5, 6, and 7. So I'm going to go here and I'm going to add 3, 4, 5, 6, and 7. So I'm going to add these numbers together. So I'm going to add 0.2269, 0.0972, 0250, 0036, and 0002. All right. And when I do that, it gives me 0.3529. All right. Again, that is 0.2269 plus 2269 plus 0.0972 plus 0.0250 plus 0.0036 plus 0.0002, and that's equal to 0.3529. All right, now fewer than 3 days or fewer than 2 days is the probability that we have less than 2 days. All right, so what does less than 2 mean? Less than 2 is 0 and 1, not including 2. So again, we're using our p is equal to 0.3, n is equal to 7, and this time we want to do 0 and 1. So 7.3, and we want to do 0 and 1. So we want to add 0.0824 and 0.2471. And that gives me 3295. Okay. So that's going to be 0.0824 and 0.2471. And that's equal to 0.3295. Right? So more than 4 days is greater than 4 days. Right? So what numbers is that equal to? Greater than 4 would be 5, 6, and 7. Right? And again, same n, same 0.3, and we want 5, 6, and 7. So 7.3, and we want to add the 5, 6, and 7. So we're going to add 0.0250, 0.0036, and 0.0002. And we get 288. So we get 0.0250 plus 0.0036 plus 0.0002, and that's equal to 0.0288. Okay. Now, the last one is at most 2. So that means that the most it can be is 2, which means it is less than or equal to 2. All right. So what numbers does that include? That includes 2, 1, and 0. Right? So in my chart, I'm still got the same N, same P, and it's going to be 2, 1, and 0. All right, so here I'm going to add up the 2, the 1, and the 0. So I'm going to say 0.0824 plus 0.2471 plus 0.3177, and that gives me 6472. All right, 0.0824, 0.2471, and 3177, and that equals 0.6472. All right, those are pretty simple, just having the table. And I'm going to do this one with you, and then I want to add one more that I don't have in the chart, so we'll make it together. All right, so the probability that a football team scores more points than the other team is 0.60. All right, 0.60. All right, it says the team takes a random sample of 15 games. So N equals 15. All right. This one says they win at most six, or they score more points than the other team in at most 6 games. So at most means less than or equal to 6. All right. So what numbers are less than or equal to 6? Well, you have 6, 5, 4, 3, 2, and 1. All right. So I'm going to go to my chart. N is equal to 15 and the probability 0.6. 15 0.6, and I want to do 6, 5, 4, 3, 2, 1. All right. So I'm going to add up these numbers. And here I don't have to add anything because there's 0. Okay, so 0.6 would be 0.0612, 0.0245, 0.0074, 0.0016, and 0.0003. Right, and that gives me 0.095. So this answer is 0.095. Right, at least 10 games means greater than or equal to 10. So what numbers does that include? That includes the numbers 10, 11, 12, 13, 14, and 15 because our N is 15. So still the same N, same P, and we're going to go 10, 11, 12, 13, 14, and 15. So 15.6, and we're going to add up 10, 11, 13 through 15. So I'm going to start with that 0.1859. So I'm going to do 1859 plus 0.1268 plus 0.0634 plus 0.0219 plus 0.0047 plus 0.0005. Right, and that gives me 4032. All right, so this is going to be 0.4032. All right. Now, fewer than 12 games. So fewer than 12 games is less than 12. So what numbers are included in less than 12? So that would be 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. Oh my goodness. So let's look and see what we got. All right, so 15 and zero point 0.6 and everything from 11 down. So I would need to add up everything from here down. Okay, so could do that, or you could do 1 minus the ones above it. But I'll just add up the ones below. So you got 0.1268 plus 0.1859 plus 0.2066 plus 0.1771 plus 0.1181 plus 0.0612 plus 0.0245 plus 0.0074 plus 0.0016 plus 0.0003. And that, oops, I got something going on. I forgot to put in a decimal. That would not give me a number bigger than 1. Let me go fix that right quick. Enter decimal. All right, so I got 0.9092. All right, so this one would be 0.9092. All right, now more than 8 would be greater than 8, which would include what numbers? That would include the numbers 9, 10, 11, 12, 13, 14, and 15. All right, so that's going to be a whole bunch of numbers. All right, so still the same N, still the same P, and we need to look up 9 through 15. So still the same N, still the same P. So we're going to go from 0.2066 down. So I'm going to start at 0.2066. So I've got 0.2066 plus 0.1859 plus 0.1268 plus 0.0634 plus 0.0219 plus 0.0047 plus 0.0005. And that gives me 6098. So this would be 0.6098. Okay, so those are fairly simple, just using the chart. Now, the next thing is the mean and the variance and the standard deviation for a binomial. So let me add a page here. All right, so this, let's make an example. All right, so let's say in a sample of 2,500 graduates of FMU, 25% did not get a job leaving school. Find the mean, variance, and standard deviation. Okay, so these are really simple. The mean is kind of what you would think it would be. If I send you to the free throw line and I asked you to shoot 10 baskets and you're an 80% free throw shooter, how many do you expect yourself to make? I would say 8. Now, how would I get that? Well, 80% of 10 is 8. So what is that? That's a P times an N. So the mean is simply the N times the P, all right? So here we have an N that is 2,500, and we have a percentage which is 0.25. So 2,500 times 0.25 is 625. So we would expect 625 people leaving Francis Marion after they graduated not to have a job if that percentage is true. Now, the variance is almost as simple. It's N times P times 1 minus P. So you're simply going to do 2,500 times 0.25 times 1 minus 0.25. All right, so if I put that in the calculator, I've got 2,500 times 0.25 times 1 minus 0.25. And that gives me 468.75. All right, now the standard deviation doesn't change. No matter what I do, it is always the square root of the variance. So we're going to take the square root of 468.75, and we get 21.7. All right, and that is the mean, the variance, and the standard deviation, just so you can see it a little bit better. And that is all for this test. If you have any questions, just send me an email or send me a reminder, and I'll be glad to get back with you and try to help you out. And again, sorry that we didn't have class on Thursday. Thanks, guys. Bye.